Hey guys, Mrs. Dan's here. Just wanted to give you a video on the answers to this review because we are going to wind up having a quiz. So be careful with your order of operations when you're doing these square root problems. So since the square root is so long, it's like you have to do the problem underneath first. So they want you to figure out what's the square root of 16, and that turns out to be 4. That is its simplified version, and it's rational because it can be written as a fraction. It could be written as 4 over 1. Remember, rational numbers can be written as a fraction, while irrational numbers cannot. We also talked about that if you take the square root of a perfect square, it is rational. But if you take the square root of a non-perfect square, it's guaranteed to be irrational. So the square root of 16 is a perfect square. Number 2, follow those order of operations. Do the 3 times 4 first, and you get 12. And you have to do 12 plus 13 before you take any square roots, which is 25. The square root of 25 is 5. That's the simplified version, and that is rational. On number 3, we do the square root of 49 to get 7, and then we add it to the square root of 100, which is 10. So the simplified version is 17. Again, this one is rational. Number 7, I already know it's irrational. I can see that they're asking me to do the square root of 50, and 50 is not a perfect square, therefore it is irrational. The directions ask us to simplify it. Please remember that simplifying does not mean change to a decimal. So if you're unsure if the square root of 50 is rational or not, remember you can use your calculator. How do you like that picture? So on the calculator, if I type in 7 rad 50, I see this decimal that seems to extend to the end of my calculator, which definitely makes me think it is irrational. Remember, all rational numbers can be written as a fraction, so you could even use your calculator. Remember the math button? Choice 1 here changes decimals to fractions. If I choose it on the answer that I just had there, it doesn't change it to a fraction for me. So that also shows us that it can't be written as a fraction. It definitely is irrational. But let me remind you how to simplify. I'm going to come a little off to the side here. I'm going to do it right here. 7 rad 50. I like to think of the rad 50 as rad 25 times rad 2. Don't forget that the 7 really is here. And then we want to simplify these perfect squares. The square root of 25 is 5, and the square root of 2 is irrational and cannot be simplified any further. 7 times 5, this is 35 rad 2. That's what this simplifies to be. Now, if you want to check and see if you even simplified it right, go back to that calculator of yours. I already know that 7 rad 50 is 49 point, all of that stuff. And now let's do 35 rad 2, and it better be the same. And it is. It's identical. So I definitely did some manipulations to this number correctly. The calculator won't tell you if it's completely simplified, but you should know that the square root of 2 is like one of our, I don't know, smallest irrational numbers. Number 5, I don't know the square root of 6, and I don't know the square root of 24, but remember there is that rule that works with multiplying. It doesn't work with the adding. That says you can multiply the two numbers before you take the square root. So if we do 6 times 24, it's 144. So the square root of 144 is 12. Now I think your calculator actually would have even told you that answer. If I do square root of 6 times the square root of 24. Remember, my calculator is not as updated as yours. You would get a little box under your square root sign where I'm getting these parentheses, so I had to close my parentheses. But see how this gives me the exact answer of 12? So you could enter this stuff into your calculator, and if you get a whole number, you know you're done. You know the answer is 12. This happens to be a rational number. We could, if you wanted to, use that calculator and type this in exactly as is. 2 rad 6 times 5 rad 10 seems like my screen is full. Must be irrational. You could try and change it to a fraction, and it doesn't. So I guess it's irrational, but let's simplify it. So I could use like the commutative property. Remember, this 2 rad 6 means 2 times rad 6 times 5 times rad 10. So if I did the commutative property, I could do 2 times 5 times rad 6 times rad 10, which gives me 10 rad 60. Now I bet you this rad 60 can be simplified. I'm coming off to the side. Things that multiply to be 60, where one of them is a perfect square. Remember that trick on your calculator. If you go to your y equals and you do 60 divided by x, you can use this list in your table to help you see the factors of 60. So we see a 1 and a 60, a 2 and a 30, a 3 and a 20, a 4 and a 15. 4 is a perfect square. It's kind of a small perfect square, so you might want to look through your list a little bit more to see if there's a larger perfect square, because sometimes there is, but in this case there's not. So we're going to do 4 times 15. So this is 2 rad 15. Don't forget I had this 10 in front of this 60, rad 60. Therefore, this is 20 rad 15. Final answer. Remember again, that decimal version is not called simplified. That's actually like considered rounding because it's irrational, so I can't write out the whole decimal version of it. Again, this is addition. I have to do the square roots first. So the square root of 25 is 5, and I have to add it to the square root of 6. And when you're adding with square roots, you can't add if the radicals aren't the same, so actually we're done here. This is more of like an Algebra 2 thing, knowing that you can't add these. Is it an Algebra 2 thing? No, we'll actually talk about it in lesson 12, I think it is, when we start using the quadratic formula. We can't add numbers together if their radicals aren't the same. So when you add a rational number to an irrational number, your answer is always irrational. And again, you can check that on your calculator. You would see the decimal version can't be changed to a fraction. Now, when we do number 8, I can choose to simplify the numerator and the denominator, or maybe you want to divide first, because we can apply that rule to division that we applied here with multiplication, that you are allowed to divide first and then square root. So that would probably be the quicker way of doing it. 200 divided by 25, I would hope that you would know this already, is, of course, 8. So 8 is underneath the square root sign, but 8 needs to be simplified. I know that it's irrational because 8 is not in that list of perfect squares. And I can think of 8 as the square root of 4 times the square root of 2. Remember, I said square root of 4 is a pretty small perfect square, but there really isn't anything larger if I have to multiply to get 8. So this simplified answer turns out to be 2 rad 2. So rewriting in vertex form, remember I like to underline the first two terms, and I undistribute the coefficient of the x squared term. So I take out the 2 and I'm left with x squared plus 2x. I leave a gap, I put my minus 2, and then I take half of this 2, which is a 1. You square it and put it here. 1 squared is still 1. You multiply this 2 by the 1, which is a 2. Since I just gave this 2, I have to take away the 2. Remember, you're trying to keep it mathematically equivalent. So f of x is equal to 2 times x plus 1 times x plus 1. So I'm going to write x plus 1 quantity squared minus 4. I always like to write this number here. It helps me remember what it factors to be. This is vertex form. This is the answer to part A. Part B is asking for the vertex. So the vertex will be at -1, -4. Remember, it's called vertex form because you could see the vertex here. Don't forget about this plus 1 is really a shift to the left one, and that's why it's a -1, -4. And now it's asking me to graph it. So I definitely know that the turning point is at -1, -4. I know that it's opening up. I know it's rather narrow. I know that the rates of change are going to be multiplied by 2, but you could use your calculator. Hold on, Amber's calling me. So you can pull out your calculator for this. And first of all, we can use our calculator to make sure that we put it in vertex form correctly. If I type in the original equation, and then if I type in what I think I did right for vertex form, when I go look at my table of values, they should be the same. And they are. I also know that my vertex is at -1, -4, so I could easily scroll to see that -1, -4. Write down some of this information. I'm going to record x values from -4 to 2. I know at -1 the value is a -4. I forgot my other values. 14, 4, -2. 14, 4, -2, and then I see the symmetry. And now I can plot. I'm only going to plot the ones I can fit. Connect with a smooth curve. Make sure it looks U-like in shape because it's a quadratic equation, which definitely makes a parabola. Label it. So I did C. State the domain. So the domain is all real numbers. Goes from negative infinity to positive infinity. Remember, the domain are your x values going out forever to the left and to the right. But the range isn't going forever up or down. It's going forever up, starting at -4. So the y's start at -4 and go forever up. Evaluate f of 0. If no solution exists, explain. So f of 0 means plug in a 0 for x. If you plug in a 0 for x, I can just see on my graph even that I'll get out a -2 for y. F of 0 equals -2. You could even see it here in my table. When I plug in a 0, I get out a -2. Then the next question, it's kind of in reverse. Find x when f of x equals -10. And if no solution exists, explain. So they're asking what x value gives me an output of -10. -10 on the y-axis is down here. The parabola doesn't come down here. So no solution exists. And you can say things like the graph of the parabola doesn't reach down to -10 on the y-axis. You can say something like -10 is not part of the range. The lowest that the range goes to is -4. So there are a few ways of explaining it. It's just that there is a minimum of -4, right? This turning point is called your minimum. The minimum is -4. You can't get down to -10. So anything along those lines would be accepted. If g of x, so this is a new function because I just graphed f of x. If g of x is equal to f of x plus 1, so it's equal to this parabola that I graphed, but then you add on 1 on the outside. How is the graph of f of x translated to form g of x? Remember, addition on the outside of the parentheses is a shift up or down. F of x would need to shift 1 unit up to form g of x. And now h of x is going to be created from f of x, and it's f of x minus 3 in parentheses. This is a shift to the right 3 units. You have to be able to explain these shifts. It's a mandatory thing. This is not too hard for you to understand. We've been doing tons and tons of shifts since we started with our absolute value functions. Also, this function notation, mandatory to know. You have to know that this is an x value when we're looking at letter F. I'm plugging in a 0 for x, they're asking me what the y is. When I word it more like g, they're asking what is the x if y is -10. Have to know this stuff, have to be able to state domain, have to be able to state range. This really is such an important question. Next page. Again, rewrite in vertex form, so I like to underline this. I see that I have to undistribute a negative, or really a -1. So I'm left with x squared minus 6x, leave a gap, and then I take half of that negative 6, which is a negative 3. When I square it and put it here, negative 3 in parentheses squared is really a positive 9. But be careful, this negative 1 is being multiplied by the 9, which makes it a negative 9. The opposite of minus 9 is plus 9. In order to keep it mathematically equivalent, whatever you give it, you have to take away. So I gave it a negative 9, so now I have to do a positive 9. This factors to be negative 1 times x minus 3 times x minus 3. So I'll write it as x minus 3 quantity squared. Combine my like terms, plus 5. Let's write down our vertex. It's at 3, 5. And now I want to use my calculator to make sure that I actually wrote it in vertex form correctly. Also, it will help me with the graphing part of it. So the original equation and then what I think is correct vertex form. You could write this as just a negative instead of a negative 1, but I don't know, I'll keep it negative 1. Take a look at your table. Everything's the same. My vertex should be at 3, 5. And I do see my symmetry. I'm going to write down some information. I'm going to record x's from 0 to 6. Negative 4, 1, 4. And we'll graph it. I already know that this parabola is going to open downward because of the negative. Because of the negative in front of the x squared, that is. Make sure it looks like a U-like shape. It's called a parabola because it's quadratic. Label it. And the domain is all real numbers from negative infinity to infinity. The range, it goes forever downward, starting at 5. To go in like from least to greatest, I could say from negative infinity to 5. Evaluate f of negative 4. That means x is negative 4. When x is negative 4, the graph will hit it. I just didn't put it on my table of values. I know I have it in my table, so I'm going to go look actually. When x is negative 4, the y value is negative 44. I'm just going to put it in my table for work. And we have to find x when f of x equals negative 4. So when the y value is negative 4. I do see it. Here's a y value of negative 4. X happens to be 0. You can even see it right here in my table. So just make sure you're understanding the function notation and answering the question correctly. Now they're going to ask us about our shifts. This is a shift to the right 4. This is a shift up 2. And you really have to know about those shifts. And final page, a square root graph. So remember, you should have a picture in your head. A square root function looks something like that. I hope you saw my notes about like the looks of functions so that you get these pictures in your head before you even start. I would use my calculator though and record some information. Again, my calculator is not as updated, so in parentheses I have to do the x minus 1. And that means that the whole x minus 1 is underneath my square root sign. You have to make sure that x minus 1 is all under your square root sign. Remember that you can't take the square root of negative numbers, so it makes sense that I have all these errors here. Record the information of the points that are fairly easy to plot. So 1, 0, 2, 1. 5, 2. And 10, 3. And I'm probably done. So and notice this curve definitely looks like what I did up here, right? I knew the picture in my head before I graphed it. Look where it is. It's like 1 unit to the right of the origin. Makes sense. Look at this minus 1 under the square root sign. Remember, that's like a minus 1 in your parentheses. Remember, my calculator actually does it with parentheses. So that minus 1 really is in the parentheses. So it shifts to the right 1 unit, right? It makes like such sense. All of these shifts are the same from function to function. So the domain are your x values. The smallest x value is at 1, and then it goes forever to the right. So 1 is included, and it goes forever to the right. The range, the smallest y value is at 0, and then it goes forever upward. They're asking me to evaluate f of 10. If I plug in a 10 for x, what is the y? It's right here. F of 10 equals 3. Find x when f of x equals negative 10. Well, do I get any negative values for my y? Does it ever reach down here to negative 10? There is no solution. We could say that negative 10 is not part of the range. Right, because this was a y value, and that's why I'm using the word range. Cubic function. Remember what a cubic function looks like, that funky little squiggle. We could put it into our calculator. You can use the caret key, the up arrow thing, and go to the third